Hello. In this video, we are continuing the lateral design of our 30 by 40 one-story shop building, and we will create the drawings for the lateral design in this video. In the last video, we talked about how to use the Shearwall Pro calculator. We had completed the calculations for our shop building. As a reminder, in that last video, we added a dormer to the building to illustrate how the roof gable data section of the calculator works. In reality, this building does not have a dormer. We added it right here. So what we're going to do is we will remove the dormer from the roof plan and from the elevations. So let's get right into it. Okay, here we are. We have our calculator here, same setup as from before, and we're going to go down to roof gable data where we're going to see how everything changes. So let's do this. So I am going to erase these lines here from the roof plan. And then I'm going to scroll in AutoCAD and I'm going to remove the, the gable there. And then I'm going to just zoom in here a little bit and I'm going to erase all of these things here. And that hatch pattern and these lines. Let's get these lines going. And now let's see how that changes the look of our roof. Okay, let's take a look and see how our roof profile has changed. We can see in the longitudinal direction for right of middle, we no longer have a dormer. And in the transverse direction, we no longer have a dormer here either, which creates wall surface. So here we have no surface, and here this changes to roof surface. So let's go ahead and make that change. But before we do, I want to point something out to you. Because there's no surface here now when we remove that dormer, and this is a sloping roof surface, our total maximum loads should change. And in fact, they should reduce. So with our dormer setup, we had no surface in the longitudinal direction, we had no surface, wall surface, wall surface, and in transverse, we had wall surface, roof surface, roof surface. Okay, let's scroll down here to our solution table and we can see that the total maximum load in the longitudinal direction for grid lines A and B is 2,664 pounds, and the total maximum load for grid lines 1 and 2 are 2,988 pounds. Let's go back up and let's change this to no surface. In the longitudinal direction, no surface, wall surface, switch to no surface. In the transverse direction, we will switch to roof surface. We will keep roof surface and roof surface at the middle of right. All right, now let's go down and see how this changes the total maximum loads. Okay, we can see here our total maximum loads to grids A and B is now 2,448 pounds, and to grids 1 and 2 is 2,880 pounds. This reduces the total maximum load to grids A and B by 216 pounds, and it reduces the total maximum load to grids 1 and 2 by 108 pounds each. We can see it's not a big difference, however, it is a difference. Okay, now we are going to switch to a different drawing in AutoCAD because I have everything set up here. The entire drawing is already created, and we're going to just ask ourselves some questions about our design, and we're going to see if what we have is the most efficient design. One of the biggest advantages to using Shearwall Pro is how fast it does the lateral calculations. This allows you to ask yourself several questions to optimize the lateral design of your structure. Looking at the calculations, we have a shear wall and hold down solution that works. A good lateral design provides a balance between minimizing hold downs, keeping the shear wall nailing reasonable, and providing something that will be cost effective to build while also not providing details that will be difficult to build, unless the building simply requires a difficult construction detail. Let's ask ourselves some questions, starting with grid line A. The initial design calls for 3 wall segments to be used, two 10-foot wall segments at each end of the building, plus the 12-foot wall segment in the center of the building. This design provides type A shear walls, which are 8 penny at 6 and no hold downs. Let's ask ourselves this. What if there's only one 10-foot wall segment designed as a shear wall? I will change this to 10 feet right here. Shearwall Pro instantly calculates that HDU2 hold downs would need to be installed at the ends of whichever 10-foot wall segment is designated as the shear wall. Now let's check for a 10-foot or the 12-foot wall segment. 12 and 12. The same result occurs if we just use the one 12-foot wall segment at the center of the building. That means just using one wall segment, no matter which one we choose, results in having to install hold downs. So we know we want to use more than one wall segment. I am going to undo that and undo that. What if we designate the two 10-foot wall segments as shear walls? Let's go ahead and make that change. Let Excel do the math. Now we have two 10-foot wall segments. Doing this provides the same result for the building as our initial design. 8 penny at 6 nails with no hold downs. Because the default nailing for any wall is 8 penny at 6, and designating the two 10-foot wall segments as the only shear walls does not change how the building will be constructed. We will remove the shear wall callout for the 12-foot wall segment, and doing so does not affect the performance of the building. Grid line B. The original calculations we performed designate the two 4-foot shear wall segments at each end of the building to be shear walls, and we do not count on the 3-foot 6-inch wall segment in the middle. Using the two 4-foot wall segments calculates each of the shear walls to be type A, and they are required to have HDU4 hold downs. Let's ask ourselves this. What if we include the 3-foot 6 wall segment in the calculations? Will that eliminate the need for hold downs at grid line B? Let's do that. So let's go here and let's add 3.5 feet. And then we'll come over here and change our shortest shear wall to 3.5 feet. And we can see down here in our solution table that nothing changes. All we would be doing if we added that 3.5-foot wall segment in the center of the building is adding hold downs that are unnecessary to the performance of the building. So I am going to undo these two changes. We will go back to counting on just our two 4-foot wall segments at each end of the building, nailed 8 penny at 6 inches on center, and using HDU2 hold downs. Here's another question. What if we designate only one of the 4-foot wall segments as the only shear wall at grid B? Let's do that. Let's come over here and let's say 4 feet. Now let's look down here at our solution table. So this does provide a solution that meets the code. However, this is not an easy solution to build. The shear wall designation changes to type C. However, it's the hold downs that create a problem. This configuration requires HDU11 hold downs to be installed, and HDU11 hold downs require PAB anchor bolts. And PAB anchor bolts require large footings to be installed, as well as more rebar and in the stem wall and in the footing. Let's take a look right here at what the footings for a PAB anchor bolt are. As we can see, the footings are large, they are deep, and they require additional reinforcing to be installed in the footing, as well as more rebar in the stem wall. So what we are going to do is we will revert back to using two 4-foot shear walls at grid line B, and we have a solution that is reasonable to build and is cost effective. Okay, now let's look at grid lines 1 and 2. Grid lines 1 and 2 are similar in that the calculations use one 13-foot shear wall on each grid line that are called out to be type A shear walls with HDU2 hold downs. Because grid 2 has more shear wall to offer in an alternate solution, let's look at grid line 2 first. Here's a question. What if we use both 13-foot wall segments as shear walls at grid 2? Can we eliminate the need for hold downs at grid 2? Let's take a look and see. We'll click into grid 2. 13 plus 13 feet. The shortest shear wall segment is still 13 feet. And look down here. Nothing changes when we add the second 13-foot wall segment to the calculations, and the result is the same type of shear wall, type A shear wall with HDU2 hold downs. Again, doing this would simply add hold downs and not change the performance of the building. So what we're going to do is we're going to undo that. We'll go back to one 13-foot shear wall at each grid line 1 and 2. Because grid 1 has less potential shear wall to add to the calculations, and we know that adding an additional 13-foot wall segment to the calculations of grid 2 didn't change anything, adding either or both of the shorter wall segments at grid 1 won't change anything either. So we're just going to leave them out of the calculations. That is one of the most powerful things about Shearwall Pro is you can optimize your design. We have asked ourselves questions to optimize the lateral design of this building, and we have quickly come up with the most efficient lateral design while optimizing the shear wall and hold down requirements to make the building efficient to construct. At this point, the calculations are finished and the drawings have the shear walls and the hold downs called out to match the calculations. Now it's time to look at the details required for this project. Every wood frame building with plywood shear walls requires some basic structural details. Multi-story buildings will require story-to-story connection details, and some more complex buildings will require even more details than what this simple shop building requires. For the structural details, go to the Designers section and then the Details page of the ShearwallPro.com website. This area is password protected and you need to be in the Shearwall Pro program to have access. All right, let's get into it. Every building starts with the foundation. So let's click on the foundation section of the website to see the foundation details. Every building needs a foundation, and many of the most common types of foundations are found here in this section. Clicking on the 1.1 Standard Foundation Detail section of the website, you will see many types of standard foundations. There are curb foundations and there are stem wall foundations. And for this building, we are going to select the stem wall with concrete slab on grade at floor foundation because that is what we have. If you scroll down to the bottom here, you click on this link 1.1 standard foundation.dwg, you download that, then in that drawing all 4 of these foundations will be there for you. Select the appropriate detail for your building and put it in your drawing. Now let's take a look at the rest of the details. Scanning through, we don't have any strip footings. We're not using any PDB anchor bolts. We don't need a footing schedule. We're not retrofitting anything, and our building is on a level lot, so we are not going to be stepping the footing. So no additional foundation details are required for this project. All right, let's go back. Okay, now let's look at the shear wall schedules and details. Okay, every Shearwall Pro project will have at least 2 details from this section, and they are detail 3.1, the shear wall schedule, and detail 3.7, the shear transfer details. Many projects will require more than just these 2 details, and because our shop building has gable ends, it will also require the gable end wall bracing detail. So we will download those details down here at the bottom, and we will put them in our drawing. And one thing to note about detail 3.7, the shear transfer details, there are 6 options for you to choose from, and the first 3 are all multiple story details, and then the second set of 3 details are for 1-story buildings. The difference comes in at the foundation level. This one here shows foundation with floor joists on it. This one here shows foundations with post and beam floor system, and the last one is foundations with a slab at grade. Okay, and this is the detail we will choose for our building. Okay, let's go back and taking a look at the diaphragm continuity details. We don't have any interior shear walls, we don't have any floor cantilevers, and we don't have any situations where we have trusses parallel or perpendicular to shear walls at different levels. So we don't need any of these details here. Okay, so we go back, and now we are going to look at the hold down details. Okay, now let's get into the good stuff right here. Every Shearwall Pro project where hold downs are called out will require several details in the hold down section of the website. Our shop is going to require 5 details for the hold downs. Detail 8.1 is the hold down schedule. The hold down schedule is what ties the hold down numbers shown in the calculations and the numbers shown in the circle at each of the hold down callouts in the drawing to which hold down is being installed in the building. This detail is essential. Because our shop is a one-story building, we will not need detail 8.2. This detail is for multi-story buildings, and this is used for story-to-story connections at the ends of the shear walls. However, we will need detail 8.4 because this is the HDU hold down detail. This detail stipulates the HDU hold downs to be used at grids B, 1, and 2 of this building. This detail is used in every building for the hold downs at the foundation level. Now we get into some juicy connection details. Details 8.9, 8.10, and 8.11 describe how to connect the hold downs to the shear wall end of a shear wall at a door opening, at a corner, and at a window opening. Let's just see a picture of what they look like. Essentially, what you're looking for is at a at the end of a shear wall at a door opening, you're going to connect the hold down to the king stud and trimmer inside the wall and not in the door opening. At a corner, when you have an end of a shear wall at a corner, here's your typical California framing, 2 examples of it, and where you can put your HDU hold down. Now, the end of a shear wall at a window opening, it's very similar to the door opening. The only difference is you flip the hold down bracket to under the window and connect it to the king stud and trimmer under the window instead of in the interior of the wall. Okay, at this point, we have selected all of our details for our drawing, and we have put them all, and I have gone ahead and dragged them all into our drawing right here. Okay, we can see everything in model space right here. Here's our building shear wall layout, and here are all of our details. Using the Shearwall Pro title block, I have made M view windows, and I have put every detail. I've put the shear walls, and I've put every detail needed for this project on one sheet. You can see we have the foundation detail, we have our shear wall schedule, and our gable end wall bracing, and our shear transfer details. And then at the bottom of the page, I have put all of the hold down details. Note that the empty box at the upper right corner of the drawing is left blank intentionally. When you send us your AutoCAD file or your Revit file, this is where we put the stamp, and then we will create the PDF and send it back to you. So now we are finished with the lateral design of this building. All that's left to do is submit the calculations and the drawings to Shearwall Pro for review. If we agree with what you have done, we will stamp your calculations and the drawings and send PDF files back to you to submit to the building department. If we see something that needs to be changed, we will contact you and we will talk about the change, and then you will resubmit your drawings and or calculations. Typically, we review Shearwall Pro projects within just a few days. If you submit a project that will take us longer to review, we will contact you to discuss it. For projects like this shop building, if you have calculations and drawings correct on your initial submittal to Shearwall Pro, we will often send back the PDF calculations and drawings within a day or two. As you can see, Shearwall Pro is easy to use and provides lateral calculations for your wood frame buildings 4 stories and less. Using Shearwall Pro to do the lateral calculations and then creating the lateral drawings using the Shearwall Pro title block gives and the details we provide for you gives you, the building designer, an efficient and cost-effective way to provide the lateral calculations for your drawings and your projects. For more information on how to become part of the Shearwall Pro family, go to the software section of the website and then click on Apply. Read through the program requirements, then fill out the form, and then submit the form to us. After you have done that, then click on the login link at the top of every page. Here you will see a place to log in and it will work for you after your user account is approved. If you do not have a login, click on the link at the bottom here that don't have an account, sign up. Then you go here and you fill out all of these details and you click register. After you register, you will receive an email from the website and you need to respond to that email. There will be a link in there that you will click on that will verify your email address. As soon as you do that, your new user account will show up in our website and we will put you in the Shearwall Pro program if you qualify. Thank you for watching this video on how to create the drawings for your Shearwall Pro project. The last video, we showed you how to use the Shearwall Pro calculator, and this video, we showed you how to create your drawings. Make sure to subscribe to this channel and ring that notification bell so that way you get notified every time we make a new video how to use Shearwall Pro. And remember, you can always submit your projects at shearwallpro.com. We'll see you in the next video.